Every 2.4 million years, Mars does something unexpected to our ocean's depths. And I've come in close to the surface of Mars. You can see the hazy atmosphere there. NASA JPL Caltech image. A slow cosmic dance between Earth and Mars has a hidden effect on cycles in the deep ocean, scientists say. According to a new analysis of the deep sea geological record, the gravitational interaction between the two planets results in cyclic changes in deep ocean currents that occur every 2.4 million years. It's a finding that will help scientists be able to better understand and predict Earth's climate going into the future. We were surprised to find these 2.4 million year cycles in our deep sea sedimentary data, says geoscientist Adriana Duguay-Twit of the University of Sydney. There is only one way to explain them. They are linked to cycles in the interactions of Mars and Earth orbiting the Sun. In recent years, scientists have started to identify what they have termed an astronomical grand cycle. This is a 2.4 million year pattern linked to an alignment between the orbits of Earth and Mars. Direct evidence of this interaction in Earth's geological record is scarce, but what we have found suggests that the peak of this cycle is linked to higher solar radiation on Earth, as well as warmer climate. And this is unrelated to the anthropogenic climate change Earth is currently experiencing. We know that other planets can influence Earth's path around the Sun, tugging it into a more elongated shape on regular cycles known as Milankovitch cycles that coincide with the rise and fall of ice ages. However, these are much more frequent, although also unrelated to anthropogenic climate change, occurring over tens of thousands of years, and they're created primarily by interactions with Jupiter and Saturn, far heftier planets than the relatively titchy Mars. The gravity fields of the planets in the solar system interfere with each other, and this interaction, called a resonance, changes planetary eccentricity, a measure of how close to circular their orbits are, explains geophysicist Dietmar Müller of the University of Sydney. Milankovitch cycles were confirmed in 1976 when scientists found they had been recorded in ocean floor sediments. Duguay-Twit and her team were looking for something different. They were trying to determine if the currents at the bottom of the ocean change when the climate is warmer, whether they become more vigorous or slow down. A break in sediment means faster eddies on the seafloor, while steady sediment accumulation indicates calmer conditions. They based their analysis on 293 scientific deep-sea drill holes around the world, in which they found evidence of 387 breaks in the sediment over the past 70 million years. While plotting these breaks over time, they noticed a curious clustering, the 2.4 million year cycle that matched the astronomical grand cycle of Earth and Mars. In addition, the breaks lined up with known periods of warmer climate, including the famous Paleocene-Eocene thermal maximum that took place some 56 million years ago, when Earth's temperature rose by up to 8 degrees Celsius, that's 14.4 degrees Fahrenheit. This event has been attributed to a number of different causes, including a glitch in Earth's orbit and a passing comet, so a potential link to Mars could be a contributing factor. That's 56 million years ago. It's a surprising finding because models and observational evidence suggest that the circulation system responsible for the Gulf Stream could shut down as global warming melts sea ice. So scientists have thought that a warming climate will result in a deep ocean that was much less active. On the other hand, major systems become much more frequent in warmer climates, producing sediment-stirring eddies that can extend as far as the deepest depths of the ocean. And this could mean that the oceans are a little bit more resilient to climate change than we thought they were. Humans still are not, though, so we should still try to do something about it. Our deep-sea data, spanning 65 million years, suggests that warmer oceans have more vigorous deep circulation, Duguay-Twit says. This will potentially keep the ocean from becoming stagnant even if Atlantic meridional overturning circulation slows or stops altogether. The research was published in Nature Communications and it's by Michelle Starr on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.